In this video, we're going to go over a mechanics question. Pause the video now and try both parts of this question. So part AI asks us to explain why the gradient of the line DE is the same as the gradient of the line AB. So in order to understand and answer this question, we obviously need to understand what the gradient represents. So it will make sense for us to explain that. So what does the gradient represent? Well, we've got a velocity time graph, as explained in the question. So the gradient of a velocity time graph represents acceleration. And so both parts of the graph, clearly then the acceleration is the same. So why is the acceleration the same? It's because it's due to the object's weight, right? Because it's a ball and it's dropped, so the ball is being accelerated by gravity, and the weight is the forces acting on it. Part II, why is the area of triangle ABC not the same as the area of the triangle CDE? So again, to answer this question, we need to explain what the area under a VT graph represents. So what does that represent? It represents the distance travelled. So this area here, which is less, is smaller because some energy is lost during the bounce, meaning the ball doesn't rebound as high. So this isn't necessarily the shortest way to word it, but will definitely get us the marks. The next part of the question is here. Pause the video now and try all parts of this question. So these questions here are motion questions that involve our equations of motion, and they also involve another equation as well. So let's look at this one. So it wants the speed of the ball immediately before impact with the ground. So this one, let's list what we know. We know that mass is 0.13 kilograms. We know that the height, which we'll call S, as our convention, is 1.7 meters. We know that the time of the bounce is 75 milliseconds. And we know that the force on the ground upwards is 16 newtons. So what information here can we use to work out the speed before impact? So it's before impact with the ground. So it's a ball that's simply moving down. So this is a big clue. It's going to be SUVAT with constant acceleration. So S is 1.7, U is 0, the initial velocity, V is what we're trying to work out, and acceleration is due to gravity. So obviously 9.8. So what equation links these things together? V squared equals U squared plus 2AS. So if we rearrange this for, we don't need to rearrange this, do we? We know that U is 0. So V is the square root of 2 times 9.8 times by 1.7, which gives us an answer of 5.8 meters per second. The speed of the ball immediately at D. So for this, we do need to refer back to the previous question so that we can at least understand what D means. So D is the bit where it's just rebounded off the ground. So it's dropped at A, hits the ground at B, there's a large upwards force, and then it's moving upwards just after the ground. So for this, we need to take into account the force of the ground, which is 16 newtons, the time of the bounce, which is 75 milliseconds, and we obviously need to find the speed of the ball at D. So I'm going to put that as the final velocity, and I'm going to take the initial velocity now, 5.8 meters per second, the answer to the previous question. So it might not be immediately obvious what equation is used, maybe it is, but there's obviously a piece of information we haven't used yet, mass. So this, therefore, is a big clue that we need to use our version of Newton's second law, that is, force is the rate of change of momentum. So now, if we plug in all our numbers, we get our velocity is 3.5 meters per second. The maximum height reached after the first bounce, and now we've got a ball off the ground, moving up, accelerating down with G. So this becomes a SUVAT problem again. So our velocity is our answer to the previous question. Our final velocity is obviously 0 when it gets to the top of the bounce, just before it comes back down again. The time, we don't know, but we actually don't need to care about. Acceleration is minus G, minus gravity, because it's slowing down. And S is what we're after. So what equation links these together? Well, again, it's v squared equals u squared plus 2as, where s is v squared minus u squared over 2a. So plug in all the numbers and you get 0.61 meters.